Welcome to Plutus. And today we are covering SN1 reaction with respect to your E1 reaction. In last class we talked about E2 elimination reactions versus your SN2, where we learned about what are the different factors that decide when elimination will occur and when your SN2 reaction both will be biomolecular can occur. We also discussed different factors, how they are affected, and apart from that, we learned why SN1 and E2 always coexist together. And in today's class, we're going to do the same, but this time we're going to restrict ourselves within our unimolecular elimination and unimolecular nucleophilic substitution reactions. Now, when it comes to defining the factors that affect whether SN1 or E1 reaction will occur, are exactly the same as in the case of E2 and your SN2. But here there will be a little much variation since we are using a different mechanism. So first thing, we are using SN1 and E1 reaction. So first thing, why we are comparing them? We are comparing them based on the similarities for this reaction that they follow. First thing, both SN1 and E1 follows first order kinetics. Both follows first order kinetics. That means their rate of reaction depends only on the concentration of the substrate that is taking part in the reaction. Second similarity is that both SN1 and E1 involve carbocation as an intermediate in the rate determining step. Intermediate in a rate determining step RDS. So that's why they are very closely associated. Now, let's try to differentiate them based on various factors. The first factor always going to be the nature of substrate, the type of species you are taking for the reaction to occur. For example, if I take a primary haloalkane or alkyl halide, again taking same kind of base, taking same kind of basis H, here I'm using HCl, then this one is primary, going to second one OH, HCl, third one OH using HCl. Again, chances of both elimination and substitution. It can take part into substitution reactions forming chloroalkane and elimination. Then here again chlorine, elimination alkene, then it should be here, then in this case Cl and again alkene. Here in this reaction, what do we found? That for primary alkyl halide, the concentration of substitution product was very high, about 87%. While the moment you switch to secondary alkyl halide, the percentage goes about 48%. In this case, here elimination product goes about 81% and your substitution product remains only about 19%. Why is it so? It can be simply explained based on number of beta hydrogens that you have. As in the case of even elimination, we have seen that number of beta hydrogen directly relates towards the tendency of the molecule to take part into elimination. Because since this reaction involves formation of a carbocation, and tertiary carbocation is much more stable than secondary than primary. So that means here elimination will prevail for tertiary, for primary will have both. Here substitution will prevail. In this case, both elimination and substitution can prevail depending on other factors. So here for tertiary alkyl halides, even elimination is always preferred. For substitution, SN1 would be preferred. For secondary, based on the condition, either SN1 or E1 both can occur simultaneously. So the product concentration do not vary much. The proportion will be very closely associated. Now, the second factor that comes in determining and explaining which type of product will be formed is the nature of base. For nature of base, you can simply remember, if you are having a strong nucleophile prefer for substitution to occur, while absence of a nucleophile, or you can say presence of a base which can attack the acidic protons, it will lead to even reaction over SN1. This can be explained by an example that in terms of concentrated H2SO4, I get elimination product as the major product, while using HCl, I get substituted product as the major product. Now, in both the cases, proton is being provided, which leads to protonation of cyclohexane, positive charge, which undergo dehydration, forming a let me this be here H2O. It will lead to the formation of secondary carbocation, which is very much stable. Now, based on the stability, now Cl minus is a very weak base but is actually a strong nucleophile because of presence of large number of lone pairs. So here the nucleophile will attack the secondary carbocation, giving substitution product as the major product. While in this case you have a weak nucleophile HSO3 minus. Here this is a weak nucleophile because the negative charge is circulating within the molecule via resonance. So instead, in this case, this nucleophile cannot attack, and hence the molecule will try to acquire stability via internal elimination and follow elimination, giving eliminated product as the major product, which is actually an alkene. For third case, we have solvent. Since it's much obvious to us that carbocation is the intermediate, which is stabilized by polar solvents, polar and primarily protic solvents. So they provide stability to carbocation. So if carbocation is stable enough, that means nucleophile can attack, because now the carbocation is stable enough that it can wait for the nucleophile to approach it. And when it does, here nucleophile will attack the carbocation and you will get substitution as a major product. So in polar aprotic solvents, we can write for polar aprotic solvents, SN1 reaction is preferred. While in your aprotic solvents, carbocation is not stable. If it's not stable, so that means there is no external stabilization to the carbocation. So in this case, the carbocation needs to stabilize itself on its own, and that can be done simply by abstraction of the proton and leading to the formation of alkene via E1 mechanism. Now, fourth and the last step, that is temperature. So, temperature increases the rate of both the reaction, whether E1 or your SN1. But the rate increase in E1 is much greater compared to the rate of increase in SN1 because of increased kinetic energy of the molecules. So both rate of E2 and E1 is increased by temperature more compared to your SN1 reactions. So I hope this would have cleared all your doubts regarding when SN1 or when E1 reactions occur and how to differentiate them, and what are the factors that decide the stability of a molecule in terms of SN1 and E1. In case of any doubt, you can add it to the comment section and we'll get back to you. Or if you have any other specific topic in your mind that you want us to make the video, you can also add it to the comment section and we'll get back to you. That's all for today now. Thank you for joining us.